Hey guys, in this video we'll be looking at how to solve more systems word problems. These word problems are going to involve three variable systems, and I'm going to teach you how to set them up so that they're a little bit shorter than the ones we did just the regular variable systems in 2.2. So just make sure you have your calculators ready, and I'll show you a little bit easier way to go about solving these systems. Okay, so let's go ahead and look at number one here. So in this one, it says you manage a clothing store and budget $6,000 to restock 200 shirts. And it says you can buy t-shirts for $12 each, polos for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? So for this problem, we're trying to find how many of each type of shirt, and I have three different types of shirts. So that tells me this is going to be a three variable system. We can go ahead and let X equal our first type of shirt. We have the option to buy t-shirts for our store. So X can be the number of t-shirts. Y can be my second type of shirt, which would be the polos. So Y equals number of polos. And Z can be my number of rugby shirts here. Okay, so now let's look at my problem and put together the information in order to make three equations. Now, for these three equations, at least one of them is going to use probably an x, y, and a z, but you're not necessarily going to use all three variables in all three equations for every problem. Some problems you will, but sometimes you'll have equations with only two variables in them, or maybe if you get lucky, an equation with just one variable in it. Okay, so let's go ahead and let's write equation number one here. In equation number one, I'm going to get from my first sentence, where it says you manage a clothing store and budget $6,000 to restock 200 shirts. So this tells me that I'm going to have a total of 200 shirts. Okay, so if X is my number of t-shirts, Y is my number of polos, and Z is my number of rugby shirts, then that tells me that X plus Y plus Z is equal to 200. Okay, so that's my first equation. My second equation, I know I'm dealing with price here in this problem. So it says I have a budget of $6,000 total. Okay, so that's going to be the total in my second equation. So I'll go ahead and start that and end it with an equal 6,000. Okay, and that $6,000 is going to come from the number of shirts I'm buying times the cost per shirt. So I'm buying X amount of t-shirts and they cost $12 a piece. So that's going to be 12X. Plus, I'm buying Y polos. They cost $24 each, so plus 24Y. And then finally, I'm buying Z rugby shirts, cost $36 a piece, so that's plus 36Z. So this second equation here is involving money. And then your third equation we're going to get by comparing the number of rugby shirts to polo shirts. And so it says down here, we want to have twice as many rugby shirts as polo shirts. So what that means is if I take so the number of rugby shirts, which is Z, is going to be equal to the number of polo shirts, which is Y, times 2, because you're taking twice the number of polo shirts to get the number of rugby shirts. Okay, so 2 times Y is equal to Z. So this third equation here is not even going to involve an X. Okay, once you get those three equations written, then you're going to start out the problem similar to what you did in 2.2, and you're going to try to get equation 4 and 5. Equations 4 and 5 need to be two equations that only have two variables in them. So either an X and a Y and a Z, or an X and a Z. For this problem, I'm going to use substitution because of this third equation down here. I know that Z is equal to 2Y, so that means I can just plug a 2Y in for Z up here to equation 1 and right here into equation 2. Okay, so equation 1, if I plug in a 2y for my z, that gives me x plus y plus 2y is equal to 200. When I simplify that, I get x plus 3y equals 200. So I'll go ahead and I'll name that equation 4. And then equation 5, I'm going to take equation 2 and again plug in 2y for my z. So that's going to give me 12x plus, I have a 24y here, I have a 36 times 2y, which becomes 72y. So it's 24 plus 72, I'm going to get 96y equals 6,000. And I'll go ahead and I'll name that equation number 5. Okay, so once you get equation 4 and equation 5, then you can go ahead and go to your graphing calculator, and we're going to graph this system of equations here, equation 4 and equation 5, and that's going to allow us to very quickly find what x and y are. So I've already got my graphing calculator here. It's set up in standard form already. So my first equation is x plus 3y equals 200. And then my second equation, 12x plus 96y equals 6,000. Okay, if you need to, feel free to move the actual equations here so you can see the intersection point. So there's my intersection point. So if I go to menu 6.4, I can draw my window and I get an intersection at 2060. Okay, so that tells me that x is going to be equal to 20, y is going to be equal to 60. And now my job is to find z by plugging these values back into either equation 1, 2, or 3. Now the easiest thing to do for this problem is probably just to take equation 3. We can just plug our y back in, 60 in for y. We don't even have to worry about x for that equation. So now if I take equation 3, I know z is equal to 2 times y, so that means z is equal to 2 times 60, and so that means z is 120. Okay, so for this problem, I know the number of t-shirts I need to buy is 20. The number of polos I need to buy is 60, and the number of rugby shirts I need to buy is 120. So for all of these 3 variable system word problems, you're going to write your let statements, set up your 3 equations. You're going to get equation 4 and 5, and then just let your graphing calculator do the rest. Okay, let's go ahead and try number 2 and set that up similarly. So this problem, you're actually given a table that contains all your information. So basically this problem says you've got 3 Major League Baseball players, Randy Johnson, Curt Schilling, and Matt Morris. Each of them has been nominated for an award, and the committee that nominates them gives them either a first, a second, or a third place vote. Okay, and so our job is to, based on the total number of points that each of these players gets, we need to determine the number of points awarded for a first place vote, a second place vote, and a third place vote. So that's going to be my let statements. I'm going to let x be the number of points for a first place vote. Y is going to be the number of points for second. And z the number of points for third. Okay, so I'm trying to find, again, how many points does a first, a second, and a third give you, and I'm going to find that given the total number of points for each player and how many votes they got that was first, second, and third. Okay, so my first equation is going to go ahead, I'm going to go ahead and use the information about Randy Johnson here. So Randy Johnson was given 30 first place votes. So that means if you take 30 times x, that's going to tell you how many total points he got just from his first place votes. Okay, he was given 2 second place votes, so we're going to add in a 2y there. No third place votes, so there won't be a z in this equation. And his total number of points, which is why he ended up getting this award, was 156. Because he got more total points than the other 2 here. Okay, my second equation, Curt Schilling, he got 2 first place votes, so we'll go ahead and make that 2x, 29 second place votes, so plus 29y, and then 1 third place vote, so plus z, and his total number of points was 98. And then finally, Matt Morris, poor Matt, didn't get any first place votes, so there won't be any x in this equation. 1 second place vote, and then 28 third place votes. So plus 28, z equals 31. Okay, now for this problem right here, to get equations 4 and 5, there's a number of different things you could do to get those equations. What I'm going to do is I'm going to do some elimination on this problem. And the reason I'm doing that is I notice in equation 1 and 3, I already have two equations that have two variables. Equation 1 has an x and a y, and equation 3 has a y and a z. So I'm going to pick one of those equations and just make that automatically my equation 4. Because again, the goal of equation 4 and 5 is to get a 3-variable system down to a 2-variable system. Well, we've already got 2 variables in one of our equations. So I'm actually going to take equation 3 here, and I'm just going to make basically that my equation 4, not going to do anything to it. And so that's going to, again, be y plus 28z equals 31. And so now I already have one equation that has just 2 variables, y and z, no x in this equation. So now I need to get equation 5, and equation 5 I need to also get rid of x. So I'm going to take equations 1 and 2 here. I'll just go ahead and I'll recopy equation 1, 30x plus 2y equals 156. And then equation 2, I'm going to multiply equation 2 by negative 15, and that's going to give me a negative 30x on equation 2, and that's going to eliminate my x. So negative 30x. Then I'm going to have minus, I have a 29y here. Okay, so if I take 29 times negative 15, that gives me a negative 435. So I'll have minus 435y. And then I'm going to have a minus 15z equals, and then 98 times negative 15 is going to give me negative 1,470. So I'll have some larger numbers in equation 5, but that's okay. We can deal with that. So now if I do my elimination here, x's cancel. See, your y's, should be one negative that sign there. We're going to have negative 433y minus 15z equals, we've got 156 minus 1470, which gives us negative 1314. Okay, and so that's my equation 5. Okay, so now I have two equations, 4 and 5 here, both with a y and a z. So now I can go ahead and I can graph those on my calculator. Now, the one thing you need to be careful for when you're doing a problem like this is, let's go back to my graph screen. Both those equations are in standard form already, but the standard form they're in over here include a y and a z, not an x and a y. There's no way, if you go back to your graphing screen on your calculator, to change these variables from x and y to y and z. So what I'm going to do is I'm going to type these equations in exactly as they look. I just have to remember that x here is really my y variable for the problem, and y here is really my z variable for the problem. Okay? So I'm going to type these in, keep the coefficients in the same order, but when I get my ordered pair at the very end, okay, when I find my intersection point, I'm going to get an ordered pair for y comma z, okay, for this actual problem. So my ordered pair that I get is going to be yz. So my first equation is 1y plus 28z equals 31. So I'm going to type in a 1, a 28, and a 31. Graph that. My second equation is negative 433y minus 15z equals negative 1314. So we'll do negative 433 make that a negative sign. And then we have a negative 15 and a negative 1314. Okay, and then we'll go ahead and I'll find the intersection point right here of those two. Intersection point is 3, 1. Okay, so that tells me for this particular problem that my y value is equal to 3 and my z value is equal to 1, and now I can use both of these to go ahead and find my x value by looking at my original equations again. So I'm just going to go ahead and plug in my y value of 3 into equation number 1 up here. So for equation 1, we have 30x plus 2 times, now we know y is equal to 3, so 2 times 3, and that's equal to 156. So if I solve this equation for x, I'll be done. That gives me 30x equals 150, and so x comes out to be 5. Okay, so now I know for first place, you get 5 points for first place vote. For second place, you get 3 points. And for a third place vote, you get 1 point. Okay, one more example. Let's go ahead and look at number 3 here. It says Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. Total order came to $589.50, and we want to know how many of each type of flower was ordered. Okay, I'm going to break this problem up into parts, so what I want you to do is pause the video, just write your let statements for me, and then click play to go ahead and see if you got that part right. Okay, so your let statements, you're just supposed to find how many of each type of flower. So our 3 types of flowers are carnations, roses, and daisies. So you can let x be number of carnations, y be number of roses, and z be number of daisies. Okay, now I want you to try to write your 3 equations, okay, and you can look back at example 1 because this problem is very similar to example 1. See if you can come up with the 3 equations on your own. So go ahead and click pause, try to come up with them. If you can't come up with 3, at least come up with 2 or 1, and then go ahead and click play to check your answer. Okay, so here's my 3 equations. Your first equation is just involving the total number of flowers. You know you're ordering 200 flowers, so x plus y plus z equals 200. Your second equation involves the price per flower, and so it's $1.50 for carnations, 1.5x, plus $5.75 for roses, 5.75y, $2.60 for daisies, 2.6z, and add all that together, and that gives you your total in dollars, which was $589.5. And then your last equation just compares the number of roses to the number of daisies. It says there's 20 fewer roses than daisies, so if you take the number of daisies, which is z, and subtract 20, that gives you the number of roses. So z minus 20 equals y. Okay, what I'd like you to do now is try to come up with an equation 4 and an equation 5. You may get a different equation 4 and 5 than I get, but that's okay. So go ahead and do some elimination. Try to come up with your own equation 4 and 5. Click pause to do that, and then click play just to compare that to what I came up with. Okay, let's compare what I did to what you did. Again, your equations 4 and 5, if you did a different process than I did, may be different. So I went ahead and I did substitution just because I had y by itself down here in equation 3. So I plugged in the expression z minus 20 for y into equations 1 and 2. Equation 1, that wasn't too bad. You can see my work up here, and that gave me x plus 2z equals 220. So I made that my equation 4. Equation 2 had to do a little bit more work there, do some distributing, combine some like terms with decimals, but that ended up giving me 1.5x plus 8.35z equals 704.5. Okay, so that gave me 2 equations, both with an x and a z. If you have 2 different equations, maybe with an x or a y and a z, then go ahead, that's okay. Those might be correct. Just plug those in on your calculator just like I'm going to do, and let's just see if we get to the final answer at the end. So my ordered pair that I get for this one is going to be an ordered pair that's x and z, even though my calculator is going to say x and y. So I'm going to go ahead and plug those in and see what I get. Okay, so my first equation is x plus 2z, so I'll put a 1 and a 2 in here for my first coefficients, equals 220, so equals 220. And then my second equation is 1.5x plus 8.35z equals 704.5. Okay, so I graph that, and then my intersection point comes out to be 80, 70. So that tells me that x is equal to 80, z is equal to 70. Okay, and so now I can use those to go ahead and find my y value. So I'll take equation 3 now. It says Z minus 20 equals Y, so I know Z is 70. So 70 minus 20 is going to be equal to Y, and so that means Y is equal to 50. Okay, so if you found two different variables than I did, check to see that they match up to what I got. You should get X is 80 at the end, Y is 50, and Z is 70. So that means that for our final answer, we know that the number of carnations, which was my X value, is 80. We know the number of roses, which was my Y value, is 50. And then finally, we know the number of daisies, which was Z, is 70. Okay, these are, I realize, a little bit longer problems than you might be used to, but again, I'm trying to shorten it up a little bit so that you can at least use your graphing calculator to do part of it. Feel free to go back through anything in the video that you need to review, write down a question or two to ask me the next time I see you. Until then, have a nice day. You're all wonderful people. Thanks a lot.